So thank you all for joining these circular industries talks, and thank you also for to the presenters for being willing to present their work here. So we have a combined presentation today. So it's 3 presentations, all related to digital product passports. So we have Boriana Rukanova and Yao-Hua and Jolien Ubacht from the TU Delft. We have Anelia Kurteva, also from TU Delft, both from different departments, and we have Teresa Oberhauser from Circularise. So yeah, and digital product passports are of course a very important thing, also with legislation coming up and with different approaches being presented. So yeah, I'm just very much looking forward to the presentation. So I'll give you the floor.
Thank you very much, René. It's really a great pleasure to be here and to be able to talk about our research. We were also very happy that we were all invited because our presentations are very complementary, and we will try to give only highlights because we have limited time, but we'll try to stick to the time, and if there are questions, we will discuss further, and of course we could follow up via email. So what I'll do is I'll start with the first presentation. It's a joint presentation together with Yao-Hua and Ubacht. These are colleagues with whom we work together very closely. And our presentation is on digital infrastructures for circular economy monitoring. So we take more the monitoring perspective and the role of digital product passports. Why are we so interested in monitoring? Circular economy is very high on the political agenda. So we see a lot of policy developments, new legislation coming. But we also see that if you don't have the proper instruments in place, the media coverage, from time to time we see these news and we see these images how, let's say, plastics that is exported for recycling ends up being dumped in Turkey, or there was a scandal with the textiles in Kenya. So it is good to have these measures that the governments are trying to steer the transition towards circular economy, but if you don't have the proper monitoring and information visibility plays a very important role for that, then things can go wrong. So how did we get interested in that, and where do we come from? We come from a long history of research in different EU projects that are on the interface between businesses, supply chain visibility, and the government, and how governments can use business data for risk analysis and for monitoring. So we have been working a lot with the customs community. So that's what you see on the top side. These are different projects we did with customs. But also we work very closely with supply chain partners, with international supply chains that create visibility solutions to make the supply chains transparent. So why is customs so interested in supply chain transparency? Well, the Port of Rotterdam, there are enormous volumes of trade coming in, and customs has a dual role. On the one hand, they need to facilitate trade, to basically control the flow of goods, but at the same time, they want to facilitate trade. They want the trade to flow smoothly in the EU rather than creating enormous queues. So that's why Dutch customs especially is very innovative. They have been working a lot in partnership with supply chains to try to see whether they could get additional access to data, business data from the source. And in return, if companies are willing to share this data, then customs could offer trade facilitation. So we have been working with these concepts. So the central part here is the data pipeline concept that was developed by Frank Hyman from Dutch Customs and David Hesketh from UK Customs already in 2010. But later on in several EU projects, it has been piloted with real pilot implementations where IT systems have been set up to create these data sharing infrastructures where government could get access to business data. So one of the pilots we did was with IBM and Maersk, one of the blockchain platforms that they developed globally. Yeah. And one of the issues that you see is that this visibility is very useful for customs. But when you talk about customs, it's like you have boxes that go in containers, for example, in China, and then you could get the invoices, the packing lists, and then Dutch customs can use this information that comes from the source to cross-validate the customs declarations coming in Europe. But the visibility that we were looking and piloting so far was from the moment the goods go into a container till the moment they're cleared in the Netherlands. We were showing some of these pilots to the Ministry of Infrastructure in the Netherlands, who is setting up the circular economy agenda. And they were very interested because they said, well, these infrastructures that customs is developing, they could be also very useful for circular economy, because we need this visibility to be able to monitor the circular economy transition. And then we started looking together with customs and the Ministry of Infrastructure to see, okay, what is needed and can we actually do something with this, these developments. And then we came to this model with extensions where we said, well, it's what we've been doing, it's an interesting basis, but it needs to be extended towards more the material composition, the production processes, so on the left side, or towards visibility with recycling and reuse. And that collaboration led to the Data Pipe project that started in September 2022. It's a 2-year project. It's funded by DG Reform of the European Commission, and it's a support to Dutch customs and the Ministry of Infrastructure to be better prepared for the circular economy transition, where the focus is to look into how to extend these digital infrastructures that the customs has been piloting with to the context of circular economy. For this project, it's conceptual. The idea is that we'll have a in-depth analysis of the problem analysis, and then we'll come up with blueprint for piloting. But the actual piloting that requires much more resources and the types of pilots we've been doing in the previous projects, that will have to be done in follow-up projects. What we do in Data Pipe, we look at the circularity of the car, and it's not because the Netherlands is a country where there is a big manufacturing industry of cars, but it's a very important hub with the port of Rotterdam for parts or cars being imported and exported out of the EU, and that's why it's important for monitoring. And we'll look first at the circularity of the car, what happens with the car, also end of life. But the car also consists of batteries, plastics, electronics, and metals. And then if we start looking into these components that ended up in the car and looking at the circular economy loops, we'll get quite interesting insights on what's happening also with the parts and materials that go into a car. So this, we do a quick scan to try to understand these circular economy processes. And the next thing is to try to map the digital infrastructures. And for circularity, it is quite likely that all the information that you need for the different parts of the process, it's likely that they will not be in one platform or in one system, but that they'll be dispersed across a different system. And then a big challenge for the monitoring is that if government wants to have this complete overview, they'll need to get access to data that resides in different platforms. And there the work of TNO comes very important because they develop a semantic model for logistics. It's called the Federated Semantic Model that is supported by DG Move of the European Commission, and the Ministry of Infrastructure is in the lead also for this development. And what we try to do in the Data Pipe project is to see how this semantic model could be further extended to allow data sharing for circular economy monitoring purposes. So that shows how we basically built on these infrastructures that were developed initially for other purposes like fiscal and safety and security controls to add to those also elements that could be useful for monitoring circular economy. But at the same time, at the European level, we see also developments related to digital product passports. And we see digital product passports as a very important development because they actually will allow to get data, much more detailed data about the material composition and track and trace the resources. And we are also part of the SERPAS project on digital product passports. It is a coordinated and support action. It's facilitated by CEA in France, and it aims to create an inclusive forum to build a common understanding of cross-sectoral digital product passports. So it's really about these cross-sectoral passports where they take batteries, textiles, and electronics, and they bring standardization organizations and all kind of NGOs and industry partners to be able to come with requirements for these digital product passports. So I copied a definition that is used in the SERPAS project, what is digital product passports, and it's seen as a structured digital collection of product-related information, including data on sustainability and circularity, and it is to facilitate circular retention, extraction, reuse, remanufacturing, and recycling. So that's the starting point, and it's foreseen that there are like 4 elements of these passports: persistent ID, persistent data carrier, digital connector, and IT architecture. So this is a starting point for the SERPAS proposal, but of course how the architecture will look like, it will take some time to see how it will materialize because the project is still running. And this is simply to give you some highlights on ongoing work. So there is overview of standards, there is review of digital product-related passport initiatives, more than 160. If you have initiative, you could fill it in by a website questionnaire, and much more information will be available on the SERPAS website with some forthcoming deliverables. Just to round up, this is we are also present at the research community, and so Jolien Ubacht, our colleague, she's one of the co-chairs of the ICT and Sustainable Development Goals track, and that's our, let's say, one of the outlets where we try to publish our research. And if you are interested, you could submit a paper by the 31st of March. And with that, I would like to conclude our talk, and now Anelia can take over.
Yeah, thank you, Boriana. Let me just share my screen. Okay. Can you see the presentation slides? Yes. Okay. So yeah, thank you for the nice introduction into the topic. Now I'll go a bit into more details and how we envision digital product passports and building them with the RePlanIT project. So just a quick motivation about our work. We know there is unprecedented amount of data that's generated every day, and usually this data is generated and processed by ICT devices such as laptops and data servers. And their average lifetime is actually not that long. It's between 36 to 60 months. The ICT sector is already responsible for 3 to 6% of the global greenhouse emission, and this is expected to rise up to 14% in 2040. And the digitization of all the services that we're witnessing nowadays is also has a growing demand for rare materials that go into the manufacturing of new ICT devices. So the main challenges that we are trying to solve with RePlanIT, or at least one of them, is the lack of findable, accessible, interpretable, and reusable data that we currently have. So with the digital product passports that we're trying to build, our main goal is to interconnect all the data we currently have. Now we have data that's spread across different silos. We have ICT data, we have data about materials, and we have different circular economy strategies and data about them. But all of this data is not connected. It's really into its own domain. So what we're trying to do is really create relationships and meaningful dependencies between the data. So what can we do? How can we do this? In RePlanIT, we are using semantics in the form of ontologies and knowledge graphs to give more meaning to data and to create relationships. And ontologies also provide a formal structured vocabulary that both humans and machine can use. And there is one structure of how all the data should look like and what should go into a system when digital product passports are built. So here I wanted to give you a quick and brief overview of our ontology work. So the main goal, as I said, is to represent and interconnect the ICT, materials, and circular economy domains. And we started by focusing on laptops and data servers as our main use cases. Here on the site, you can see just some of the concepts or things that we have represented that we want to include in our digital product passports. So we have different types of ICT devices, such as computers and data servers. We have also represented different types of hardware components that can go into these ICT devices. We have the different circular strategies that we can apply, and much more information. And all of these concepts are connected between each other with, here on the right side, you can see specific relationships. Here, due to the page limit, it's not really possible to show you everything, but between each two concepts, as I will show you in the next slides, we have a specific relationship that connects them. And the main goal of this ontology that we're developing in RePlanIT is to help manage and extend the life cycle of laptops and data servers. And we also want to provide digital product passports that support both the human and machine decision making. So on the human side, we have decision making such as procurers and companies who want to become more sustainable and when they procure different ICT equipment. And on the machine side, we have different processes such as predictive maintenance that can use all of the information from our digital product passports and help extend the lifetime of ICT. For those of you who are interested really into the details, we have an online documentation of our ontology, so you can access it via the link. And there we provide a lot of details and explanations about each one of the concepts and the relationships between them. So here is just a visual representation of what is happening on the back end. You can see we have represented the concept of an ICT device with our ontology. And this ICT device, we can say it has different components, such as CPU, display, also storage. We can specify the different characteristic of the storage. For example, we can say it has a RAM size, ROM size. Then with ICT devices, we also want to represent their materials. In RePlanIT, we model materials on two levels, either a hardware level, hardware component level, or the whole ICT device. And we have represented different types of materials that go into the production of ICT, such as metals, sometimes ceramics, and polymers. We have also different sensors that can help monitor the status of the ICT device and provide some dynamic data, such as performance over time, maybe energy consumption. We have also the related digital product passport that comprises of all this information that we have represented about the ICT device. And we have, for example, a circular strategy that can be applied to this ICT device. And this information is also recorded in our digital product passport. And we have the specific agent. This could be an organization, a person, or a software that's responsible for the circular strategy and its execution. And we have, of course, different roles for each person who is responsible for that. We have procurers, remanufacturers, refurbishers. And here I wanted to present to you actually how a digital product passport can look like when we add the real data to our data model, our ontology. All this data that I've shown here is real data that we've collected online. So we can say that we have a MacBook Pro, which is an ICT device, and this MacBook Pro has specific operating system. We can also say that it has warranty 2 years and it was purchased at a specific date and time. We can go further into details and also represent the specific material composition of this ICT device, such as how much copper there is in it, how much steel, plastic, and aluminum. We can also present the specific hardware components of this laptop device, such as the storage device, its hard drive, and how much ROM and RAM size it has. We also have the graphics card, and in this manner, for each hardware component of the device, we can specify details and values. We can also say that this ICT device is currently under repair, and the reason for this repair is a specific failure, such as a camera damage. And for each process, such as repair, that is currently happening, we can specify its status. Here we can say it's in progress, and we can define the specific date and time at which this process started and also ended. So in this manner, we can represent for any ICT device, currently laptops and data servers, a digital product passport. And this is just some of the information that goes into it. And I really suggest going into the online documentation that we have if you really want to see all of the concepts. Currently, I think we have more than 200 different data types that can go into this digital product passport. So thank you, and if you have any questions, feel free to ask and also send me an email. Yeah. So thank you, and I think Teresa, you can continue from here.
Yeah, thank you very much, Anelia, for that overview on the ontologies, and it's my pleasure to basically connect the dots from a very practical perspective of the two presentations that we've just heard. Let me put it on screen. Yeah, I mean, first of all, if we look at the presentations of what we've heard about the developments around the digital product passport, how it's been set up, and what kind of research is undergoing there, actually from the side of TU Delft, but of course a lot further as well. University Leiden is a big actor in that as well, of course. And the work that Anelia has defined around defining what we are actually doing and how we're doing things when it comes to digital product passport, because when it started, it was of course a whole idea, and if we want to create a globally accepted digital product passport, we need to speak the same language and understand the same things. And from Circularise's side, this is something that I would like to just put a little bit into perspective on a very practical small example, which is our operations as well. Circularise is a company that creates a digital product passport on a distributed platform, so on a blockchain system. So we're a commercial company, and we have actually since 2016 provided digital product passports. And there's some very interesting lessons learned from this example that I will highlight while walking you a little bit through what we do and what it actually looks like in practice if you create digital product passports for an industry that might put some of the things you've heard into a little bit of a visual understanding. So let's be very frank. When we started in 2016, digital product passport was not there yet. There was not a lot of legislation around supply chain traceability, transparency. And also when it comes to circular economy, there was not a lot yet. So I can say that we've seen a lot of positive developments towards that over the last years. And we've also seen how difficult things were in 2016 in making the case for the digital product passport for supply chain transparency and circular economy. Why? Because, of course, a lot of the feedback we got from companies was there's currently no underlying legislation that suggests that we have to be more transparent, that we have to talk about what kind of materials are in our product and what are the details about our product that should be shared globally. So one of the most important things was indeed for us taking that one step further and making clear official guidelines and legislation around that help us, of course, when it comes to reaching circular economy and, of course, supply risks, if we look at, for example, critical raw materials. But it also helps for the companies to understand the way forward of what is expected from me by when. And, of course, for companies like us, it helps to give to really fine-tune the service that we're providing to the legislation that is out there, and to go with official standards instead of what we think is needed. So Circularise was launched in 2016. We have 40 employees in total. We've been scaling a lot over the last year with a Series A investment, and we are fully commercialized and have a European patent as well. Our main focus, of course, has been on creating traceability along supply chain to drive growth, mitigate risks, reduce costs, and of course, the most important component right now, to fulfill the requirements around the digital product passport, and of course, the supply chain acts on the national level and the European developments around that. Same thing, of course, when it comes to legislation around eco-design, with also the new directive on that, the DSSB, and the basically previous arrangements on eco-design. Legislation is one of the most important drivers, and of course, secondly, the sustainability that companies would like to see within their own supply chains, because as you know, circular economy itself does not necessarily present a best business model to companies. Closing the loops, reusing materials, extending lifetimes of products, and refurbishing, repairing, remanufacturing products by itself is not a business model. So that's why we, from a very early stage onward, looked at circular economy and digital product passports in there as a possibility to create new business models for companies. How would we do that? One of the most important things is, of course, that companies are right now already moving towards more sustainability when it comes to recycled content or sustainability, sustainably sourced materials, whether that's environmental aspects or social aspects. It doesn't really matter, but all of these in one entirety. And one of the most important problems here is, of course, saying you are using recycled material or a more sustainably sourced material is one thing, but actually being able to prove that back into the early steps of your supply chain is very, very hard, and often even becomes impossible. So that's basically where we used a fully decentralized technology on blockchain to track the digital product passport and material data that goes even beyond the current mandatory legislation, and reflects many of the things that Anelia has pointed out in her overview of what kind of data is relevant right now, and what kind of data is expected to be relevant for the future. Because as you know, right now, supply chain transparency looks mostly like that. People in supply chains, tier 1, tier 2, tier 3 suppliers, sending email back and forth with Excel tables of, can you provide me information about what's in your product, what kind of compliances you are fulfilling, and so on and so forth. And then suppliers really bilaterally communicating about this and trying to gather that from earlier stages of the supply chain, which of course is super labor intensive. It is very prone to error. It is not updatable as such. It's very reactive. And of course, it also doesn't give us the proof where the data really comes from and if it's trustworthy, because it's not coming from the original source necessarily. Now, what we designed is a system that, based on blockchain, decentralizes that whole process. What does it mean? It means we're basically communicating a communication channel where all the different stakeholders that you can see here on screen are connected to this communication channel. That means that every stakeholder actually communicates about the material and product information for their specific supply chain step, and that is then connected and communicated further. That means for OEMs, they have the possibility to actually reach their supply chain through these channels. Same goes for, of course, research purposes, if it's opened up to research, or for recyclers, and so on and so forth. And of course, it allows the different stakeholders in the supply chain to communicate positive aspects about their product. So basically the incentive model to see how can we help companies that are already maybe producing in Europe or sourcing more sustainably or using recycled material content. How can we use these transparency and digital product passport methods to help them as well in getting more visibility and communicating the positive things about their product, which I think is a very important thing to communicate, because the digital product passport is always, of course, it's a requirement and so on, but there's also possibilities for companies to use that positively, that we hope will also lead to more transformation towards circular economy and a bigger acceptance of the digital product passport. Yeah, our system basically works on locally stored data from the different stages of the supply chain, a proof of the locally stored data on the blockchain, and then the accessible data to the company. It's a decentralized system where every stakeholder for themselves keeps their local data stored, or asks us or others to store the local data, and then basically communicates that via a blockchain hash, which means the data ownership always remains with each single supplier in the supply chain, and they can decide how much do I share with whom and how. So basically the possibility to create such a digital product passport, but to de-risk it for companies. De-risking, how de-risking? De-risking by making sure that companies can, for themselves, decide how much they share with whom, by making sure there's no big, powerful, giant database that basically stores all of the sensitive data, but basically making it possible for companies to never store any of their sensitive data on any external database or anything like that, but still be able to communicate about it in a way where they can basically design how much is shared with whom and how. Most important here is, of course, keeping the ownership with the company, and secondly, thereby increasing the acceptance of such policies by making it 100% sure that none of the data can be leaked. So companies can basically opt in for different types of questions and digital product passports from their suppliers. Either, of course, standards that are being developed or companies that are already using the system. Here, of course, we have started creating digital product passports for some of the customers, but only because there is still, as you've heard from Boriana and from Anelia earlier, if there's still a lack of standardization in what the digital product passport should exactly look at, like in the different industries. So I can say not just from Circularise's side, but I think in general in companies that are consulting around that as well, are all waiting for more standardization in that field to then reflect that properly in their services that they're providing to companies. Now, just to, in the end, show you 2-3 visuals on what it could look like. In our case, these are all real examples from our customers. What it looks like is really possibilities to use a barcode or a QR code in the product that you then scan and make available to either people internally in your supply chain or even publicly customers, what is in the product, and all of that with the possibility to also share with customers the positive sustainability parameters of that around with mass balance, what kind of percentage of recycled material am I using in the product, by proving that further material data that's interesting to share with customers as well. And of course, within the supply chain, the possibility to analyze your own supply chain and get an overview of the chain of custody, life cycle assessment data, chemical composition, and so on. Within the different stages of the supply chain, all data from the different stakeholders here that they are managing and providing, with the full responsibility through the claim on the blockchain that this data is actually based on the original and ideally audited data to provide more clarity and proof of data. And that, of course, we are working with a blockchain solution to make it as public and private as possible in terms of data governance, a trustless system, and of course the possibility to collaborate with different stakeholders, because of course this is something that should become an industry standard where we all have to work with each other to create an open protocol. And something we've been working with and had good experiences implementing a digital product passport in not just the polymer industries, but many other connecting industries like batteries, electronics, and so on. With some visuals of how that looks like for the practical cases here in the automotive sector. Another one in the luxury goods, in this case a suitcase with recycled material content tracing of the exact amounts of mass balance proven recycled content and chain of custody of materials, and same with bio-based materials as well. Yeah, I'll cut it here to make sure everyone else also still has enough time for questions. Handing over back to, I think, Boriana in this case, if I'm not mistaken.
No, I think we finished that. So back to René. Thanks.
Thank you all. Thank you all for great presentations. Very interesting to see the work that is going on, and also the connections between the work is I think a very interesting thing to discuss also maybe. So I would like to open the floor for questions. So if you have any questions, either digitally raise your hand or as far as there's no hand raised at the moment, you can also just open your mic.
Yeah, I would like to ask a question. First of all, thank you for all your presentations. It was very interesting to hear, and nice to see you, René. Last time was in my thesis, so that's been a while. I had a question about the sort of field of tension between this search for standardization from legislation versus retaining user flexibility, or according to what is required for a specific product or use case, and also the manageability of the system. So if you require a lot of details, maybe it also makes it more difficult to manage all of that information. So what is your how do you balance that? I guess that's my question.
I didn't fully understand who the question was for, but maybe that was on my end. Is that
I didn't specify.
Okay.
It could be for any one of you.
Who would like to answer?
I can start, and then probably the others can fill in. So something, maybe a reflection on SURPASS. SURPASS is a project where now they are looking into this cross-sector standardization for the digital product passports, and they look at batteries, textiles, and electronics. And what you see is that when it's in a specific sector, it's super detailed. I mean, they come with so Anelia already mentioned 200 data elements, I think. Textiles very similar. Like you see, this complexity is enormous, and probably when it is about a sector, that's how they think about it. That there will be these ontologies that will be developed for a specific sector. What we also notice is that, and that's something we are struggling with, is that at some point when you have to go through different, let's say, data spaces. Probably you need to go to a high level of abstraction to be able to share information, because when you are in a specific domain, it will be very detailed, but when you have to go, from example, from producers to recyclers, etc., you might need to get to a high level of abstraction. And there are these more upper level ontologies that the TNO is developing, but also some other parties, they play a role. And probably I would also like Teresa and maybe Anelia to reflect on, because in DataPipe, that's one of the challenges, is what I said is if you have to cross these multiple systems, they'll come with their own ontologies, with their own communities. But for monitoring, you need to be able to pop through these and to get to some level of detail. So maybe Teresa, you could explain how you look into this interoperability when you go beyond the Circularise system and you need to connect and get data from other, let's say, platforms as well.
Yeah, no, thank you, Boriana, for that. I think happy to give a bit more practical examples to the research-based answer. Yes, it is, of course, a difficulty. We need standardization in this field. But what we've seen a lot is that there is a decent amount of standardization already in the results of the different digital product passports that we have. So for example, in our case, when we started working with one company, we put together their question list, as we call it, smart question list on what kind of information do they want to receive from their own supply chain. And we have many situations where when we start working with a new company, the questions they have and the format is very similar to previous ones. So within the system, we've had rarely any issues of very different definitions within our own customer base. Now, in going to other systems, we work with APIs a lot. So of course, it's very important to be able to access, first of all, data from the ERP system of customers. And secondly, of course, if we look at the larger scale and possible calculations, you need to be able to collaborate with LCA databases and so on and so forth. So that as well is possible through API integrations. And beyond that, Circularise is also working on basically open communication protocol to basically support interoperability between platforms in the future.
Thanks.
Yes. Well, what I can add is maybe from technological perspective, when building such systems that are really data driven and dependent, it's really important to consider scalability and how the system is built itself, because we have really a lot of data, but this data is usually not of good quality and a lot of processing needs to be performed. And having a semantic model on ontology, for example, can help filter out or just select the data that we really need, so we don't overload the system and slow down all the processes we are executing. Yeah.
Can I ask a contract question to Wiebke? Because you're mentioning retail flexibility, can you explain the background of your remark?
We are at the moment looking at a material passport for a set of buildings that are being designed. So it's a bit bigger scale than the examples we saw today in terms of product type. But we've been researching what kind of information needs there are, or what information we want to include in the material passport. Mm-hmm. And one of the questions that has come up was that on the one hand we want to actually include as much information as possible, because you don't know yet in 40, 50 years from now if components of the building will be dismantled, what they're going to be used for and which level of detail is required for that. On the other hand, you also want to sort of limit the information requirements, because the system should be easy to manage for the people who have to upload the data and monitor it throughout the life cycle. So it should also be an easy to use tool. And so we've been sort of struggling with, how much detail do you go, and how do you manage it?
And so it's also about, do retailers, for example, still have the opportunity to deliver to, before, for example, buildings being built. So it's talking also about the supply chain from the source towards the buildings and project developers. We actually have good connections at TU Delft also with the architecture faculty, which looks a lot into indeed building passports. So it's a familiar, and it's a special case because they're talking about very long life cycles of buildings. So very interesting. What I always think of, if we set up such architectures, how do we connect also smaller companies that cannot maybe, easily come up with the investments to connect? And the solution is to build APIs for smaller companies, but it can have an effect also on the supply chain and the actors that are able to participate in the supply chain. And that also has to do with, upfront investments to be able to connect to the systems. I thought you were going into that direction, but it's clear, yeah. Building passports are very fascinating as well.
Yeah, thank you for your answers.
Yeah, thank you, Wiebke, for your question.
Yeah, and if I may still add one point to that, I think it's really interesting, something we see a lot with small companies, especially in the upstream of the supply chain, that say, our customers are starting to use these systems and we don't really know what we're getting ourselves into and what we can do or not. And that's where, in our case, I mean, whether this is without or with Circularise, where we've seen a lot of advantages of a decentralized system, because you can you remain the owner of the data, and it's also possible, as you have this kind of established communication channel, it's possible to basically increase the amount of data you're sharing the more trust you get into the proceedings in the system and the collaboration with other partners. So it's not like a one-time data collection where you collect it once and then you have it all, and you can't really get back and revise and update it with whatever developments are happening. So that's something I can definitely recommend for smaller companies.
So it can actually be also a competitive advantage for smaller companies. Yeah. Okay.
I don't see any hands raised at the moment, but I do have a question myself. So one of the things that we have been discussing here also is because we also are, if you look at life cycle assessments, we're always struggling to get the right data. Let's say for especially complex products, it becomes very easily undoable if you want to go to the nitty-gritty detail. So one of the ways in which we the directions that we're thinking in is making use of let's say disassembly of products, looking at parts and taking it from the other side. Let's say so one way of doing it is of course go to the producers and then trace back where all the components come from, etc. Another way of doing it is just taking a product, taking it apart in all the little details, and then from that try to make some kind of inventory at least of the elements that are there. So I'm wondering whether that kind of approach is also used or maybe even as a validation or something like that, or something like that you can get part of the information from those types of sources. Is that something that you have been looking into or using, or yeah? Do you think it's interesting?
Maybe a reflection on the data pipe project that we are trying now to conceptualize. So we actually decided to start, similarly, to start from the car and then think, okay, what's in this car? And then we look at the metals because we set all these modules, and then, okay, what kind of metals, and then the high volumes, and then the steel, okay, what is it, and can we trace it? So it's not tracing everything, but to try to say, okay, what it makes sense. And then if you think about steel and then how many cars are, let's say, process end of life in the Netherlands, can you do it if you start segregating, if you streamline this steel back to, let's say, the steel manufacturers? So actually that's very similar type of thinking we are trying to apply, because it's very complex. You can't, but if you think about materials, then you could say, okay, it's either the critical ones and where are they and how do we get them, or is it about the high volumes? So that's what we are kind of experimenting with. Auto recycling in Netherlands, we are also working very closely. And and there you could go to certain parties that have a kind of central role. In the Netherlands, for example, most of the cars end of life are dealt by this party. They have control, they have an overview, they have also their counterparts in Europe. So you could start doing things. They are also on a more volume level, and so just some reflection on our side.
Perhaps in addition, some further what was pointed out in the presentation, what is really key is if you can collect data from different perspectives and from different suppliers, that at the end you always have a unique identifier. So in the case of a car, it's called a VIN number, and that is crucial. And that was also, Anelia was also pointing out to that, and also Teresa, that in particular, if the data resides with the supplier, that you really have the unit of analysis should have a unique identifier, like a PC or a car. And that's a very important requirement. And later you can add data, but that it always comes together at one point, because otherwise you don't know how to do the life cycle assessment for a specific PC or a specific car.
Thanks. I would like to give the audience one last chance to either open their mics or raise their hands. Nothing here. So then I would like to thank you very much, all of you, for your presentations. As you know, the presentation will also be available for some time online, so people can also watch it later if they like. It's only for a limited amount of time that it is available, but that at least gives people the opportunity that were not able to make it to this meeting. Thank you again for your presentations. I think this is a very exciting type of work that needs to be done and is being done also within the framework of legislation that is designed at the moment. So yeah, this is not this will be a work in progress for quite a while, I think, before we get bored by it. So I think it's really interesting to see that so many of you are working on this, and also in different from different perspectives. So thanks again for joining our Circular Industries talks, and yeah, hope to see you with the next one also for the audience.
Thanks for inviting us, and yeah.
Thanks a lot.
Nice day.
Lisa.
Thank you.
Bye.
Bye bye.
Thanks for having us. Bye bye.